In this question, we see that the lines kx minus 2y plus 4 equals 0 and 3x plus y minus 12 equals 0 have an angle of 45 degrees between them. We'd like to know for what value of k this is true. Well, the way to approach this question is to ask ourselves what's the normal vector of the first line and what's the normal vector of the second line. Looking at the coefficients a and b in the first line, we see that the normal vector is k negative 2, and looking at the coefficients a and b in the second line, we see that the normal vector is 3, 1. Well, we're also told that there's an angle of 45 degrees between them, and this is a dot product opportunity. We see that if we dot the two normals, then what we can do is use the dot product formula to introduce the angle between them and then hopefully solve for k. Well, on the left-hand side of the dot product formula, we're going to use the component method. K times 3 plus negative 2 times 1. In other words, 3k minus 2. Then this first normal vector has a magnitude of square root of k squared plus negative 2 squared. And the second one has a magnitude of the square root of 3 squared plus 1 squared. Cosine of 45 degrees is, of course, 1 over root 2. And so we see that 3k minus 2 is equal to this quantity times 1 over the square root of negative 2. Well, what we can now do is square both sides. 3k minus 2 times 3k minus 2 is 9k squared minus 12k plus 4. Squaring this quantity gives us k squared plus 4. Squaring this quantity gives us 10, because the square root of 3 squared plus 1 squared is equal to the square root of 10. And squaring that, in other words, the square root of 10 times the square root of 10, equals 10. Similarly, squaring 1 over root 2 is equal to 1 over root 2 times 1 over root 2. The numerator, 1 times 1 is 1. The denominator, root 2 times root 2, is 2. So we have developed into this formula. Now 10 times 1/2 is 5, so we can simply distribute a 5 into this bracket and we get 5k squared plus 20. Since we have a quadratic in terms of the variable k, we can try to get all our terms on one side. And when we do that, we get 4k squared minus 12k minus 16 equals 0. And therefore, factoring out the 4 and using trinomial factoring, we get that 4 times quantity k minus 4 times quantity k plus 1 equals 0. Well, that would mean that k minus 4 is 0, which means k is 4, or k plus 1 is 0, which means k is negative 1. It's always a good idea in these situations to check. We've done some square rooting and some squaring. Checking both of our values for k, we see that if we let k be 4, then 4 negative 2 dotted with 3 negative 1 is equal to this value here, which would mean that theta is 45 degrees. So k equals 4 works. Similarly, if we check k equals negative 1, using the dot product and expanding out, solving for the cosine of theta, we see that theta is 135 degrees. But of course, if two lines intersect at an angle of 135 degrees, that's the obtuse angle in between the two lines. An acute angle would be 180 minus 135, which is 45 degrees. So k equals negative 1 is also a valid solution, and we've got two solutions to our problem.